Hi class. Today we're going to the end of Module 6 review. So we have a packet here, similar to the one that you will do independently, but slightly different. And it's going to look very similar to the end of module assessment as well. So this is a good chance to go over everything that we've learned this module and have a chance to practice with some sample problems. Let's take a look at what we have here. So the first problem here says that we are going to use the picture graph below to represent student eye color. So each set of eyeballs is two students. So two students, two students, two students. So this is a total of, I'll just write it next to it, 6, 2, 4, 2, 4, 6, 8, and 2. And then it says use the grid to create a labeled and scaled bar graph representing the data from the picture graph above. So we're going to take the picture graph and turn it into a bar graph. So let's see if we can get everything on one page here. So I'm going to say that we're going to go with blue, green, we're going to go with brown, and hazel. And then we're going to go 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So this is my eye color on the bottom. And this is the number of students on the left. And the title is Student Eye Color. And since there are 6 students that have blue eyes in this blue column, I'm going to go up to 6 and shade it in. And then green has 4 students, so I'll go to the 4 and shade in 4 blocks. After that, I'll find brown having 8, which is all the way at the top of my graph here. So I'll go all the way to the top line with this bar and quickly shade in 8 squares. And last, 2 kids have hazel eyes, so we'll mark that just like that. And I've now created a scaled bar graph representing the same information that came up in our picture graph before. Part B says how many more students have blue or green eyes than brown eyes. Blue or green, so that's 6 plus 4 equals 10. Blue and green is a total of 10 versus brown, which is 8. Brown equals 8. So we need to compare the 10 and the 8. So 10 minus 8 equals 2. So 2 more students. Let's move that down so you can see a little better. I've said to you guys a lot this module that the math on this sort of thing generally isn't terribly difficult. It's reading the direction and understanding that you're combining blue and green first and then comparing it against brown. So that's a reading comprehension issue, not so much a math issue. So pay really close attention to that as you're going through this. And just in general with your math, we've talked a lot this year about how important it is to pay close attention to directions. All right, the table below lists the number of shows the number of vegetables planted in Jamie's backyard garden. So far it hasn't asked us to do anything, it's just giving us information. Next, it says complete the table by filling in the number of pumpkins that Jamie planted. This is exactly like the work that we did in lesson 9. We know that if we add carrots, pumpkin, and peas together, we're going to get 75. But we're missing a piece right now. So we have to add the 2 that we do know together and see what's missing. So we have, I'm actually going to do it like, well, I guess I'll do it this way first. 20 plus 25 is 45. And we need to compare that to 75. So 75 minus 45 is going to give me my missing piece. A turnaround factor that would be like my missing piece plus 45 equals 75. And this is going to be 30. So 30 pumpkins should fit in there. Now, a way to double check that is to go 20 plus 30 is 50, and 50 plus 25 is 75. You should always add them back up when you're done and make sure it adds up to your total to make sure that you got the correct number in there. The next part says, use the lines below to create and label a picture graph using the data in the table. Determine a picture scale and represent the number of each type of vegetable. So I don't know, I'll make a triangle equals 5 vegetables. So let's say carrot. Let's say, actually, you know what? Let's make this 10 vegetables. And let's make this something not a triangle. Carrot, pumpkin, and peas. Let's make it 10 vegetables. And let's make it a circle. So a half a circle would represent 5 in this case. So let's say we have carrots, 10, 20. So 10 and 10 is 20. Pumpkins, 10, 20, and 30. I guess I could have done this with 5s and I would have been just fine. I was looking at the number 75 and thinking I didn't want to do 5s all the way up to there, but obviously none of my vegetables themselves are 75, so I actually should have used that 5. And you know what, because of that, I made a mistake. I'm actually gonna go back and change it because I think it's better to show you that way. So I apologize for that, but there's a better way to show you, so I'm going to do that. So a circle equals 5. So 5, 10, 15, 20, 25, 5, 10, 15, 25, 20, 25, 30, and 5. I went too high. I messed this problem all up. 5, 10, 15, 20 on carrots, 30 on pumpkins, and 25 on peas. So I did make errors here. This is important. I made a lot of errors as I was doing this. Frankly, I got a little distracted because I think one of my kids is in that door behind me. He's trying to get my attention. So I got distracted, like happens in class sometimes with you guys. But I was able to look back at my work and understand that I made a mistake and fix it. So that's what's important, is to be able to look at your work and understand how you can correct it. And understand that we all get distracted, but it's important to try to move past that and make sure we're doing high quality work. And I'm doing the same thing here myself. All right. Jamie measures the height of all the bean plants in his backyard. His measurements in inches are shown on the line plot below. So I'm going to do the thing that I told you about. We go high, low, count by. My highest number on here is 15. My lowest number on here is 13. And then what am I counting by? 13, 13 1/4, 1/2. I'm counting by 1/4. Okay. So this is always do this. It's always important. It's good practice to be in. Each X represents one bean plant. That's important. How many bean plants are in Jamie's backyard garden? Explain how you know. We've done a problem like this a lot. If each X represents one bean plant, then the number of X's equals the number of plants. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 bean plants. I know, because each X equals one plant, and there are 15 X's. So because there's 15 X's, that means there must be 15 plants. If you added that to your description, that'd be better. I'd love that. What are the 3 most frequent measurements on the line plot? Write them in order from shortest. There's 2 steps here. Write them in, figure them out, and then write them in order. So which ones happen well, my camera got all messed up there. What happened the most? Frequency means, like on a line plot, it means which one goes up the highest. Well, there's this one. That's got 4. This one has 3, and that one has 3. Nothing else. Like if I draw a line here, nothing else goes above that line. Just that one, that one, and that one. So shortest is 13 3/4. Look, they're already in order for me. The second one is 14 1/4, and the third is 14 3/4. Like the ordering part, the shortest to longest on here, that's not that difficult to do after you've already made your line plot because you've already put them in order. They're already in order from shortest to longest, moving from left to right. All right, last page of our review here, and then I'll send you off to do your own work independently. Nina measures the length of string that she cuts to make necklaces. Her measurements are recorded in the table below. So we have 1, 2, 3, 4, 1, 2, 3, 4, 16 measurements on here. Make a line plot of the string data. Explain your choice of scale. So I'm going to make my line plots first. I'm going to go high, low, count by. So my highest number on here, let's look for that first. 54.5 so far. 54 3/4 is bigger, so I'll put my finger there. 55 is now the biggest. 55.5 is bigger. 56 is now the biggest. Nothing in this row column is bigger than 56, and nothing in that column. So 56 is my last one. Now let's find my lowest. Okay, 54 is the lowest. See if there's anything lower than 54 here. There's not. So 54 goes over here. And what am I counting by? 54, 54.5. Oh, I see a 3/4 there. I see a 1/4. I must be counting by 1/4. So 54, 54 and 1/4, 54 and 1/2. 1/2 is the same as 2/4. 54 and 3/4. I'm going to have to make this a little longer. 55, 55 and 1/4. 55, 1/2. 55 and 3/4, and 56. So now I go through, now I've done the hard work. All right, I'm going to show you that a little closer. Like I have my number line set up already. Oh, my pencil's in the way. I have the number line set up for you. Now I just have to go and match them basically. So 54 and 1/2, put an X there. 54, put an X there. 54.5 again, put an X. 54 and 3/4, put an X. And we just keep going through this process the whole way. I'm noticing a trend here. We're marking a lot of 54.5s. Okay, so I've completed that, and I should have 20 things on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm sorry, I should have 16 things, and I do have 16, so I've done it correctly. Now it says exchange your choice of scale. That means, why did I count by 1/4? And the reason I counted by 1/4 is that by doing that, I knew that I would capture or make sure that I got everything that was in this chart as long as I started at 54 and went up to 56. If I just counted by halves, I wouldn't have gotten there. And if I just counted by whole numbers, I wouldn't have gotten there either. I would have missed the things that ended in 1/4 or 3/4. So it's important to count by fourths in order to get everything on the chart, the line plot rather. And last, it says how many more strings measured 54.5 inches. So let's 1, 2, 4, 5, 6, 7, 7. Then both 56 and 55.5. So 56 was 1, and 55.5 was 2. So let's add those together and get 3. So we're comparing our 3 and our 7. Well, 7 minus 3 equals 4. So 4 more strings. Again, this math, 7 minus 3 equals 4, is not challenging for you. What is challenging is reading this problem and understanding exactly what it is that they're asking you to do. So that is a good review of the work that we've done in this module. If you have any questions about it, please let me know. But we will be taking our end of module assessment in our next class. And I know that you'll be well prepared. You guys have done a good job in this module, and I'm proud of all the hard work that you've been doing.